Hi. Class 6, let's get into some Java. We're doing inheritance. I'll do some examples, and then I will introduce the studio. Tonight could potentially, I always say this, it could potentially be a little shorter, mainly because the studio, in my opinion, is a very long studio, and I actually don't expect anybody to really get it done unless if the IAs do most of the work for you. So it is a very long studio. This idea of inheritance. So inheritance, most of this copy and pasted from the book, but there are 4 pillars to object-oriented programming. You will not need to memorize that. Like people through college feel like they have to memorize it. So I have a student, I taught in high school. He's going to college right now, and he can spit all 4 of these off to me right now, but that's because the professor said, hey, you need to know what these are. And so he memorized them. I don't think they're going to ask you in a job interview, though. But we do need to know what inheritance is. So the second bullet point definition, inheritance is a mechanism in object-oriented programming that allows one class to be based on another class. So you inherit certain properties, thus receiving its properties and behaviors. So just for reference, there's the 4 pillars of object-oriented programming: data abstraction, encapsulation, inheritance, and polymorphism. Polymorphism is something that we'll talk about next class. Encapsulation, remember, that's just like taking and breaking off this code over here that it runs kind of by itself. And when you can call it, but when you call it, it does all the work for you. So you don't have to like rewrite the code. Just like math.square root, you just need to do math.square root and type your stuff in there, but you don't actually have to program what it's doing. You're using somebody else's code. It is encapsulated, like capsule, it's encapsulated for you, so you don't need to know how it works, as long as it works. And then data abstraction, that's more of the data part of it, but a similar concept. Okay. Through a lot of vocabulary up here. Again, I like doing the live coding more than these vocabulary things, but you do need to know what these are. So superclass, or a base class, or a parent class. I will call it a parent class. You do need to know that it's a superclass because we'll be using that super keyword. So whenever I use super, that means I'm trying to access the parent class. So in the examples, that was like the cat class. Your subclass or derived class or your child class, I will call it a child class, is your house cat example from the book. Whenever you have a cat and a house cat, there are certain properties that you can inherit because a house cat is a type of cat. So, it walks on 4 legs. So you know that it inherits that property. We will use the super keyword. So that just means go to my parent class and go get it. Whenever you have a class or a method, when you have a method in your child class that also has that same method in your parent class, you do this @override, and that tells Java to override the parent class, ignore it. I want to use this child class instead, or a child, I keep saying class, child method instead. So you override methods. It does bring up that idea of an object class. Remember, everything besides your primitive types is an object. So strings are objects. Your cat is an object. And so it naturally, even though you don't say extends object, it extends object. So anything that's in the object class, you can do in every class. For instance, the toString method. Every class inherits a toString. So then whenever you make your own toString method, it automatically puts that @override right above it. That's because it already has a toString method. You're overriding the object toString method. It does bring into question abstract classes and methods. That'll make more sense during the live coding. But abstract classes are classes that you cannot instantiate. Meaning, if I made cat an abstract class, I could not do new cat. I can't make a cat anymore. I can make a house cat that implements all the cat stuff, but if I make cat abstract, I can't use it. I cannot implement it anymore. Casting, there's a couple questions on casting, like how do we do that? What do we do? I'll briefly talk about it. Casting, I'm going to try to come up with a better example, though, of casting for next lecture. So I'll talk about it today, but I'll try to come up with a better example for next time. Testing inheritance, it talks about testing. I'm not probably going to talk a lot about testing. Class diagrams, on the other hand, are very important. So when we go to Studio, the reason why the Studio is so long is because the first thing you need to do is diagram your classes. You need to say what fields and what methods these classes should have in them and how they're connected. That structure is the most important part. So once you go to Studio, creating your class diagrams, whether it's in code or on a piece of paper or however you guys do it, that is the most important thing out of Studio. If you don't get to actually implementing your Studio, for my sake, I'm not as worried about that. If you fully understand why and where your fields and methods come from and how you would implement them, that's the most important thing out of the Studio today. So hopefully there was a lot of talking during Studio. It does bring up this thing of one-to-one relationship versus one-to-many relationship. We will talk more about those exact words when we talk about database. So when we get into SQL database, those will make, we'll solidify those, but hopefully it just makes sense. If you have like cat with house cat, if that was the only thing, that'd be one-to-one. But if I have cat with house cat and tiger, well, now cat is a one-to-many. So hopefully that just makes sense. You don't overstress on that right now, because in our case, you just do what you need to do. You don't have to overthink about that. These are the pictures from the book about these class diagrams. So you need to make sure that you know how the classes relate to each other. But the main thing was this one on the right-hand side. So if I have a student, what are all the fields? Well, every student has a name and a student ID. What methods do I want? Well, they just put the setters and the getters in here, but you could, add a class list, or, like there could be other methods. But this kind of format off to the right, it really does help you whenever you're trying to design things. You're thinking of all the attributes and then all of the actions. So remember, the top part here are attributes. What does a student have? Like what properties? They have name, student ID. They can have first name, last name. They can have address. They can have parents, whatever else. Those are attributes. Those are kind of like nouns. And then there might be some actions that you want to perform on these students. And then that's where the methods come in. Whenever I do my class diagrams, I usually don't write all the setters and getters, just because those are, a lot of writing. Or I'll do a set get, like you don't have to spell each one of them out. So these are more for personal, just blueprinting for you, but these are going to be important for the Studio today. And then also, even if you don't draw it, you need to know how all the classes align. So the class A up here is your like cat class, and then class B could be a house cat, class C could be a tiger, class D could be some other cat, and then class E could be a subclass of that. Just knowing how everything aligns to each other. I'll be answering these. I'm going to look in the chat first, and then I'm going to answer these. Yeah, somebody answered that one, but yes, I will. What do you mean that you can't implement it? That'll make more sense in code. I'll show you that. Yeah, and another reason why I don't do too much with the setters and getters is because once you do the properties, you can just right click, generate most of this code. I care about all the stuff that it won't auto generate. So. Questions. So there was a question about what really gets passed and available to child classes. Technically, everything gets passed to the child class. And I'll show that better in the live code so you can see that. The thing that you have to be mindful of, though, if you don't make it available in your parent class, then it will also not be available in your child class. And that will make more sense with the live coding. But technically, I think there was a discussion of, well, it does inherit everything. But if you don't allow it to access it, then it won't be able to access it, even though it does inherit it. What is the best way to create a package in IntelliJ? Your studio is going to make you create a new package. So right at the end of this lecture, I'm going to create a package. I will create your studio package. And I'll try to go just slow enough that if you wanted to, you can almost just listen to me and then do it, so you don't have to see what I'm doing. But I will show you how I do it. You can do it however you want to, as long as it works. And then there was a question about when and how you would use casting. I will show just a little tiny bit of this, but this is a question that I think I can better explain if I had a little bit more time to come up with a better concrete example. So I'm going to write it down again. So I will make sure that I come up with a better example and show it next time. The cool thing about next time, we are going to be talking about a lot of these same concepts next time as well. So whenever you talk about abstract classes, and then you talk about interfaces, there's a lot of similarities with those. So some of these concepts will be told again next time. Right. Expectations. The biggest thing is graded assignment 1 is due on Monday. I don't want to, put too much stress on you, but as you have heard from other people, some people already have this thing done. It's one of those, again, you're adding like 20 lines of code. The hardest part is just staring at code, hitting the run button, printing out things, running the tests. A lot of it is that, not just actually writing the code. So if you have not at least gotten the part 1 where you're printing everything, then you are behind. If you've printed everything and you're stuck on the second one, that's where you need to start asking good questions, whether it's in your studio group, your IA, or generically. But I haven't really seen a lot of questions pop up, which hopefully means that everybody's really good with it. On the other hand, if you're not really good with it, I should be seeing questions by now. So I'm concerned that I'm not seeing questions. So yeah, I will show you how to create a package. Oh, getting the no results to print. Once you get it to work, you're like, well, I should have already known that. It is one of those, like, you just that's how coding is. So it goes back to, if you're it's just one of those things where the first time you do it, the second time you do it, it takes 10 hours, and then the fifth time you do it, it takes 10 minutes. Get used to that. It will always take you longer to understand and do it the first several times. So okay. I think I've answered everything that I absolutely need to in there. Let's get to some live coding. Again, I am all over the place, so I'm going to be bouncing around. But the last thing I will do is we will add a new directory and call it Studio, and we will set up a Studio package for you right here. So don't worry about that right now. The first thing I want to do is make sure that you guys are good with what was given to you. So I'm going to close all these real quick. I will make this slightly bigger because I think I can. And then I'll just open up the ones that I care about. Okay, so my main class is connected to my house and my cat, my house cat and my cat. So I think I don't think I added anything to this cat. The house cat, I don't think I added anything here. This is what was already there. I just want to do some call outs as I run this. So the first thing I did was I said, make me a new house cat, give it a name and a weight. I do think this is, yes. So I said, make a new house cat. And because it's a new house cat, I go to the constructor of the house cat and it says I need a name and a weight. And I'll explain this here in a second. I'll show that again. And then I said, get family. If I control and click this, it returns family. And the family is like a feline, whatever that scientific name is. I did say, let's go ahead and print out house cat noise. I converted it to cat, and then I said, print out the cat noise. And let's see what happens here. So it says here, oh, I need to run current file. So right here, it says, hello, my name is Philip. So the noise was, hello, my name is. Well, if I look here, with the noise, it says, hello, my name is. So then the interesting thing was, and this is, it's still like, it's one of those things, don't think about it too hard, because usually you don't do this. But I said here to change this to cat. And so cat is a cat, and the cat.noise should be meow. I said cat, which is cat, meow. It should be meow. Whenever I saved this as this, I mean, it pretty much tells me here, casting house cat to cat is redundant, meaning if I go back up to the parent, it still keeps all the attributes. I have right here, I have set all of the attributes from the child and the parent because the child inherits the parent. So I have set all of the attributes and methods right here. Whenever I convert it to cat, it doesn't really do anything. So whenever this noise here, it's still going to house cat. When I tried to cast it, if you see, whenever I don't even cast it, it just knows what it's doing right here. Just making sure. I'm seeing a lot of chat, and so I'm making sure I didn't forget anything. The other thing that I wanted to do, I'm going to set a breakpoint right here. This is my favorite part here. I'm going to set a breakpoint, and the reason why, whenever I go on to debug, and I go in here and I actually look at my house cat and my cat, even though even though I said, make my cat a cat, if you look down at cat, it is actually a house cat. It has all the other stuff. It has the weight, because I don't think our cat has a weight. I think the cat, oh, it does have the weight. It has, what does the house cat have that it doesn't? A name? Yes, cats do not have names. House cats have names. If you find a cat on the street, unfortunately, it's just cat. If you bring it into your house and it becomes a pet, you give it a name. So right here, this cat still has a name, but it's because I said this cat is actually the house cat. That's what I declared here. Is I said, I don't know why I hit that button. Hold on. I said right here, this cat is house cat. So it's binding those to be the same thing, even though I tried to convert it to cat. Now that's different than if I did it the other way. So let's mess up some code, because I like messing up code. So let's at first do cat. And this cat that I found, it weighs 10 pounds. So that's like a cat out on the street. I found it. It's just out there. And then whenever I hear that cat have some noise, it says meow. So that's exactly what we thought. But now I brought the cat inside. So now it is a house cat. I'm going to make this so that we can see that it was the house cat. Right? It should not like it. Yeah. Whenever I convert this house, that's what I want to do, set a breakpoint. We tried to convert this thing. Did it not? Hold on. Right. So right here we have a cat, and it's going to actually tell me, it knows what I'm trying to do. It says that I'm going to get a class cast exception. Where's my next button? Down here. Here it is. Right here, whenever I try to cast this, you cannot easily cast from a cat into a house cat. This is not advising you to bring the cat that's feral outside into your house and make it your pet and give it a name. Okay? It's easy to go one to the other, but not back. And actually, I could, if I made it a house cat. Okay, so let's get a little trickier here. Okay, so what I did here, originally, I went and I got a house cat. It's a tame cat. I named him Philip. But I didn't like the cat. I kicked it outside. So now it's just a normal cat. My house cat becomes a cat. and we've already done this noise thing, but I'll set a breakpoint here in a second. Kicked him outside. He's a cat now, but then I felt super bad. And then I brought him back out inside and I casted the cat to be a house cat. So then let's see what this does. So this says here, my house cat has a name. And even though I kicked him outside, it says it's still a house cat. It's a house, like that's what it was. So let's go to the next line and see if I get a house cat number 2 here. And it says here, house cat number 2. Now I can cast it just fine. So if I originally have a house cat, I cast it to a cat, and then I pull it back to a house cat, that is perfectly legit. But if I originally start with a cat and then try to cast it to a house cat, you cannot do that. So that's exactly what it is. So they're talking about memory location. Do you guys see that this says house cat at 463? This is at 463, at 463. All of these cats refer to the same memory location. When you cast from a child to a parent, you actually aren't casting anything. You're just calling it another variable, but you're pointing to the same exact memory location. That is why whenever you have a cat and you try to cast it to a house cat, you try to point a house cat to a cat object in memory, and Java does not know what you're doing there because that's not possible. So, okay, you cannot make a parent into a child. All right. I will be able to come back to this if you have any questions, but the whole point of all of this is that memory location thing of if I make a child, if I cast it to a parent, it still is the same object as the child, which is weird to think. I can see how that can be confusing at first, but it's just something that you need to memorize. So. All right, let's do, somebody asked for an example. I tried to come up with a casting. This isn't the exact casting that you were talking about, but I also like this because it gets us into what we will be getting into by the end of Unit 2. The whole reason we have this Java is because we want it to be an API, meaning we want to be able to throw in a JSON string from a front-end service. So do you remember, it doesn't look exactly like this, but do you guys remember seeing something like, this is your JSON image. It has an open brace, curly brace, and then it has your different attributes. So this is what a JSON string looks like, key value pairs. This is exactly how I would handle this, even when we get to it later. We have what we call a mapper. We're going to take this. Do you see how this is a string? I'm going to change it into an object mapper, and then I'm going to change it into a JSON node, and then I can actually cast, because my JSON node is a data type. I can do get name and then cast it as a text. So this is something that we will be doing, except for we actually won't be casting the name, age, and student. I would have made a person class. I would have made a person class that had a name, an age. I'm not going to type these out. Age and is student. And then instead of casting them to strings, I would cast it to an object. and say that it's a person. But that's exactly what we're going to be doing later in this course, is grabbing JSON, casting it however we need to, and then being able to do stuff. So again, I don't think it was a very good example because this is a lot of information that you don't know much about. So I'm trying to find up a good example where I can give you that would make more sense to why we would cast. But I do want to have another example for you. So this one, I think started with the example, and then I just started expanding. So whenever you, and to be honest, I didn't come up with some of these attributes, when we can change them if we want to. But my program, I'm going to, let's close these. Right. So my program is my runner class. So this is my static void main. So that's what I have here. And then what I did was to better talk about classes. I don't think the computer class you needed to have to be abstract. I think it was one where, I don't know if they told you. I don't know if did I have to create these exercises? Oh, that's what I did. I just, I went inside where the cows and the cat and everything else, and I just made another folder right here. I just made a package. So I went to Java and I said new package. And then I just added all my stuff right here. That's what I did for this one, but for the studio, I will show you how to create a whole like project. And actually I'll create a module, but I'll talk about that. But yeah, I just went into my Java and I just said my Java folder, and I did new and then package. That's how I created that. Remember, package and directory for you guys should pretty much mean the same thing. It's just a folder. The test directory, did they put it in here? You did have to make sure that this stuff is in here, this test. If the dependencies of test aren't in there, it wouldn't have worked. Be honest. So what I do is, like, if I go up here and I do source, it gives me like new directory, and I would do this thing right here. And then it would create the test in the Java for me. And then I would do the cat test. And then I would do the that's how I would do that. So again, I went to my source. I said new directory. Now, my test one's not there anymore because I already have a test. But that's where I found this. And then I just created my stuff. And then once you do the at test and actually build it out, it should work. Hopefully that makes sense. Yeah, it does need to be in this test directory that has, hopefully that makes sense, so you can go back to it. And if you still have problems with it, I could probably talk on the side. I think these are all the ones I need. Okay, so to go back to this program, this is the example that they were talking about. Create a computer class. This computer class has at least 3 attributes that you can do setters and getters. I guess I didn't do setters and getters, but then has at least one method. So increase RAM and increase storage. Those are pretty straightforward. At the same point, you probably would not have done super at this point. So to go into this super, if I control click on this, it actually goes to my abstract entity. I will talk about the abstract entity, but I don't want to focus on that right now. If you did not implement this abstract entity, you are perfectly on par. You're doing everything you need to do. I will talk about this though, so that you can better understand that. But originally, you probably did not have this super in there. You just had something like this. And so you had different attributes that you wanted to set. You can do setters and getters. So I could just go in and hit generate setters and getters. You can click however many you want to. So now I have that. I did the generic toString. The only reason I did the generic toString is because whenever I print out my computer, I want to actually see the attributes of my computer. So you don't have to do that, but I did it because whenever I go over to my program and when I say computer 1 equals new computer, and then it wants storage, and then it wants RAM, and then it wants to know if it has a computer or it has a keyboard. So I can print, I can just say print computer 1, and when I run this, it'll actually print out the RAM storage and has keyboard. That's the reason I do the toString method. You don't have to do it. I just do it so that I can see this here. If I did not do the toString method, if you remember, then when I run this, it'll say computer at a memory location. So I don't know what's in there. So that's why I do this. All right. So a computer, there are different types of computers. There are laptops. There are desktops. I'm going to help. We're going to create that I'm going to create that right in front of you. And then there's this smartphone, which I guess can be lumped into computers, right? It's a mini computer almost. So just to keep going with this, let's say that you don't want somebody to just say computer. Like computers, too vague of a term, don't want somebody to be able to create a new computer. That's when you would go over here and set this class to be abstract. As soon as I make this abstract, it tells me that there's two classes that inherit it. That's going to be my laptop and my smartphone. I've already created those. But my related problem is I said, hey, create a new computer. And it says here, computer is abstract now. You cannot just create a computer. I can still create a smartphone. I can still create a laptop, but I cannot create a computer anymore because I made it abstract. So let's get rid of that. Let's go to laptop. Most people know what laptops are. Again, I can make these different if anybody has better suggestions, but I said, let's add weight. So a computer, you still care about the storage, the RAM, but now I care about weight. Now, I could set this laptop to be whatever, but I'm using this super, and remember the super says, it goes up here, it looks at what it's extending, and the super goes to this constructor, and it wants to know storage, RAM, and has keyboard. So with these laptops, I'm generically saying a laptop, which is not a tablet, which a tablet I could probably add a class of tablet, but I am setting the computer storage, the computer RAM, and I am not asking somebody, does your laptop have a keyboard? I'm assuming that all laptops have keyboards. So I went ahead and just manually made this true every single time. But laptops, I also care about how much they weigh. I could also do screen size. I'm going to do an int, a rounded screen size. Like you're just going to round it. Oh, let's make it double. So then I would do double screen size. All right. Once I have that, I can go ahead and do all the setters and getters that I want. Do you see how here, the setter, it doesn't let me do the setter and the getter for the storage? Remember, the setter and the getter for the storage, because storage is a part of the computer class, I have to do the setters and getters in the computer class for storage. That's where it's getting this. The only unique fields are these for this. So I'm going to just go ahead and make all the setters and getters there. There's this thing of is clunky. So if it weighs more than 5 pounds, it's going to say true. If it's less than 5 pounds, it's false. And again, I made a toString method. My problem was my toString method wasn't very good because if I do the generated toString method, all it does is tell me my weight and my screen size. It does not tell me my storage. Because again, my storage is kind of bound to the computer. So I could do what did I say? Storage equals, and then I need to actually get the storage. And again, the storage doesn't live in this class. I could do a get storage. That's perfectly fine. And then the other one was RAM. I can't just name the variables because they don't live in this class. The other thing I can do so anytime I say super, that's the same kind of concept as this. Remember, this dot whatever is anything in this class. Super dot whatever is anything in the parent class. So if I do super, then I can do get RAM. You know, I could have done this right here. Now, IntelliJ is smart enough to know I don't have a get RAM in this class, so it must be from the super class. Like IntelliJ is smart enough to know that. So if I control click this get RAM, it actually takes me into my computer class and knows that it's going to use that method. So again, I can say super.getRAM. I can say just get RAM and it implies the super. So I don't need to say it. The other thing you can do is do any method. So I could do even a super toString, because remember there's a toString method up above. Now the problem here is it's going to restate exactly what I have. It depends on how you have it set up that you can, you know, chain these two strings together. But I just kind of throw that out there. The computer extends, I will explain, we can just delete this for a second. I will add that back in. So everything we've talked about now, do not worry about that. That's this thing. Okay, so with laptop, so now I can go back over to my main, and now I remember if I said computer, computer one, here's where the interesting part is. I can save this technically as a computer, or I can save it as a laptop, and we'll see what the difference is here. What does it want? It wants storage. So 1,000 RAM 8. This is 4 pounds. It's a 12-inch, say 13-inch. Right. Again, let's print it out. And let's see what it shows. So it says here that I have a laptop. It has a weight, it has a screen size, it has a storage, it has a RAM. And then again, if I wanted to, I can say, well, all the computer components, and remember, this was the toString method for the computer if I really wanted that. I'm going to go in and delete that because I don't want it. But it does pull from the toString method of the computer if I wanted to. I'm going to go into my laptop. I have everything from these methods that I need. I don't need that one. So then the question is, can I make a laptop? I'm going to say computer. Right. So right here, I made a computer, but I said my computer is going to be a new laptop. So let's see here what happens here. If you notice on the second one, I'll put little things in there so you can actually see the lines a little bit better. Okay, so it says one lap. Do you see, even though I listed it as a computer, because I used the new laptop key, like that constructor, it actually made a laptop. It did not make a computer. So again, this is that part of like, this is describing in memory how it allocates all the attributes in memory. It's going to say that it's a laptop in memory, even though I said computer. So then the question is, well, why even have computer? There's two things. One, your computer, if you want attributes that are stored across different types of computers, then this is that separate or that dry method. You know, don't repeat yourself. Where if every laptop, smartphone, desktop all have storage, RAM, weight, then you don't need to put all three of those attributes in every single class that you make. You can just make one class, potentially even make it abstract so that you can't call just that type of, those attributes have to be paired with a more specific type. And then you can make these laptops and smartphones have other attributes as well. So I'm going to create a smartphone. What does it want? Storage. Right. So now I have a smartphone. Let's see what it shows. Oh, it says it's a computer. Says it's a computer. These other ones say laptops. Even though I said this one's a computer, it said laptop here. The interesting part is it's actually not a computer. It is a smartphone. If I run my debugger, this is a part of programming. I purposely made not a mistake, and I overlooked something, but on purpose. If you look at smartphone, it actually says smartphone 1 is a smartphone. It says in memory, it's allocating a smartphone memory. But whenever I printed out my console, it said it was a computer. That is because I did not make a toString method for my smartphone. So whenever you start adding complexities of layers of classes, just remember that you will come across things absolutely like this, where you have like this assumption of something and you just need to verify it. So whenever I do a smartphone, my smartphone does not have a toString. So if I go over here and generate a toString, and again, it's just number of selfies. It doesn't tell me all the other stuff that I want. I guess I'll do storage first. Screen size. Laptops have screen size. I didn't put a screen size on my smartphone, but I did have RAM. There we go. So now whenever I rerun my program, it'll say smartphone because that's a string, not because of the memory. It was always a smartphone. The computer acted like it was a smartphone. The reason this did not say smartphone is I said, hey, print out a smartphone. I did not have a toString method. So guess what toString method it used? I did not override the parent one. The parent one, which is the computer one, said computer. So it was using the parent toString, not the child toString, because I never created one. If you added a laptop feature to the computer, then the smartphone would also inherit it. So let's say that I did decide, let's say this was a store, and so every computer has to have a cost. Every computer. That also means that I need to somehow set the cost. Double. But that also means I'm going to have some problems, such as in my smartphone, whenever I called this, it's now going to want cost. Also on my laptop, it's going to need cost. Hopefully that makes sense. I'm actually going to take this out because I just looked at time and we're running a little behind. You cannot make yeah. Nope. This one. All right. Why is that now saying? It says it. Forgot to remove it from up here. That's one of what was going on. So then the question was, well, what if I made this class not abstract anymore? That doesn't have any bearance on the child classes. Like a parent class can be abstract, it could not be abstract. It does not affect the child classes, but it just allows me to now do a computer. And I know this was not the question, but I just want to make sure. Now it allows me to do this. So then the question was, well, if my computer's a real class, can I have my smartphone class be abstract? And I guess technically, I don't know if I've ever seen this in real life, but technically you can make this an abstract class, but then you can't make smartphones. So abstract just means that you can't create an object of that, an instance of that. Meaning, if I said smartphone was abstract, then I cannot use new smartphone. I can't do it. So I'm going to make my computer class abstract again. And that means now whenever I try to make a computer, now I can have a computer data type, but remember in memory, it doesn't think of it as a computer. So right now, it's telling me already that it does not like this. It's when I say new computer, it tried to force me to make a whole new class right here because my abstract class, it won't let me do this. So abstract cannot make instances of that class. All right, two other things I got to do. So this is going way longer than final means you can't ever, final is like, it's not quite like final because final means that you can't really manipulate it. Anyway, actually I've got three things. First of all, I created a laptop, a smartphone. The whole reason about the good thing, and this also goes into interfaces more than abstract classes. So I will do this again. So do not worry that this will come up again. But let's say I wanted to make an array list of all three of these. Remember when you make an array list, I have to assign a data type in here for it to be. And if I want laptops and smartphones, because they're types of computers, to be in the same array list, I can't do this because when I try to add it, computers.add, I can add laptop 1. I can add computer one, because that's a laptop. Or maybe not. Because I signed it as a computer, it's saying, hey, I need a laptop. The whole one reason and I'll explain this more in interfaces, because I've used interfaces in this method in this way, but abstract classes do the same thing. If I say that my array list can accept computers, I can actually accept any computer type. So my array list can actually have different types of computers in them, as long as they're computers. And so then I can do a for each computer. So instead of printing these out like this, if I have them all, and of course, I wouldn't just want to do it to print, but let's say I wanted to do something with it, find which of these had the largest amount of RAM. I can do that because I just iterate over them and see which one had the biggest RAM. But right here, you can see that it prints out 1, 2, and 3, just like before, 1, 2, and 3. But then when I iterate over this, it actually prints the 3 things out. Two other things I wanted to show. One was the abstract entity. This is how I did it. So LaunchCode gives some solution code, and they tried to use these at ID and at generate value. These will make more sense when we get to the ORM, which is the object relational mapping or model. Anyway, when we get to the database stuff, we will be using these annotations, but you can't just magically add them in here. So they try to do this. What I did was I said every abstract entity is going to get an ID. I'm also going to have a global ID. And then what I'm going to do is I'm going to set the ID to be the global ID and increment the global ID. The key thing I did here was made this static. Because this is static, the global ID stays in it does not get created over and over within each object. I wish I had a better way to explain that, but what I'm going to do right now, I'm going to set this breakpoint right here. I'm going to look at the actual okay. Inside this laptop, I now have an ID method here. And if you look here, ID is 0. My computer 1 has an ID of 1, and this has an ID of 2. If you also notice, do you see how none of these have a global ID? So global ID or static, either attributes or methods are kind of like held outside the object. The instance of the object. It's held in the class as a whole, but it's not held as like, for instance, these do not have a global ID. They don't get binded to every instance. The static stuff does not get binded to the instance. So my ID, because it's not static, every single time I say ID equals global ID and I make an entity, it gets bound to the object. My static never does. That's why this thing works, is because my static is kind of sitting out globally. I called it global ID. It's not technically global, but it can only be accessed inside this class, but I can manipulate it, such as like if I do plus equals 10 here, and I rerun this program, now my laptop has 0, this one has 10, this one has 20. I'm able to manipulate my ID by assigning it to be my global ID and then changing my static global ID. Here's the other question by somebody else, though. Whenever I want to get my ID, so if I want to do sout smartphone dot get ID, you guys see that the method here, get ID, is here. I can actually return the ID because I made this public. If I don't make this public, I can no longer access the ID. On the other hand, as we can see in the memory, though, like this is our memory bank here, this still has an ID. So the parent still passes in the ID to the child. But if I don't tell it how to actually retrieve it by either a setter, a getter, or the worst option is making this public. If I made this public, I would just call the ID. Do you see now I can just call the ID like we did in JavaScript? I can call it like this if it's public, but if this is private, I can't call that. And so in Java, you never do that. All fields are public or private. All fields are private, but then we do like a getter or setter. And so I should make a public getter. And now I can do public get ID, and it would print the ID. I've said a lot of things here recently, so I'm going to answer questions, and then I'm going to show you how to get started on the studio, and then we will keep going. If you did test and you did the at before each, yeah, some other things could change. Can there be multiple parent and child classes in the same package? Every child can only have one parent. So you can't have, my laptop cannot extend smartphone. You cannot extend multiple classes. So when you're talking about abstract classes, you cannot do that. It can only have one parent. When we talk about interfaces, there are ways to bring in other things with interfaces, but those are slightly different, and I'll talk about those next time. So good question, though. You cannot extend more than one class. I'm going to try my best to help you get started on the studio. Again, in my opinion, you won't have enough time to finish everything on the studio. The first thing the studio is going to make you do is make a new project. Even though it might tell you different names, it might tell you different locations, or it might tell you whatever, it really doesn't matter as long as your stuff works. So in the inheritance, I'm going to go ahead and create a new directory called Studio. It didn't like my stuff because I didn't close out of all my programs. They were still running. Okay, so I made this directory. It's a folder called Studio. Now what I want to do, there are two different ways to do this. I think what I usually do is create another directory. This is going to be my root directory of my project. And what is the studio about? It is about quizzes. That's right. So it's about quizzes. So fun with quizzes. So I'm going to call this fun with quizzes. Okay. You don't have to make this new directory here. I can show you how that works. But I think if you make it here, the problem that a lot of people have, and it's just a vocabulary thing, there's projects and then there's modules. And for you guys, they mean almost the same exact thing, except that whenever you do a project, it can have modules inside of it. So I'm going to create a module. Even though it says create a project, I'm going to go up here to new. While I have my fun with quizzes highlighted, I'm going to go up here, go file, new, but instead of project, which you can do, I'm going to do module. And again, this is just going to make IntelliJ like that I keep all this stuff together, because projects, it wants separate module. You can have multiple modules in a project and they look the same. So I'm going to hit module. If you have this thing selected, it will bring that directory in here. But let's say that I didn't create it. You could type your name right here, whatever it is, and then just make sure that it's in the right location here. So you could just have made the studio, and then if you highlighted the studio, this would be studio, and you'd be like, no, I don't want the studio. So then you would hand type this and just make sure that you put it in the studio. So either way works. As long as this is your module name that you want, and it's in the studio folder. The rest of this stuff, it's Java, Gradle. I'm doing 17, Groovy. We're not going to put a parent. We can add sample code. All that's going to do is it's going to make a main class for you, so you don't have to create the main class. It'll just have a main class. You can do that if you want to. The only other thing that I sometimes mess with is this group ID. Oftentimes this is org.examples. If you leave it org.examples, everything will work perfectly fine. No worries. I just like to always change this to the same, so it's the same thing. And then when I hit create, I'm just going to, come on. Right. Mine happened really, really fast because I just deleted this before we started this. Yours should have whenever you do yours, it's going to take a little bit. So my suggestion is, right as soon as we're done here, go ahead and make this, then take your 5 to 10 minute break so that it has time to run, so that whenever you come back, it's up and ready for you. But it should have created this kind of structure for you. Yeah, it should be pretty straightforward there. So I do want to go over the studio just a little tiny bit so you know what you're doing once you get into it. You're going to be creating a quiz program. And again, the design is more important than the implementation. My goal, if I have time next class, if I have time, I will show, well, no matter what, I'm going to show this next time. If I have time, I might explain some of it for you. But you're going to create several different classes. First, you're going to have questions. So it talks about design. You have a multiple choice checkbox and true false. When I was reading this, I don't know what vocabulary they use with question types, but a multiple choice is a question with it says a fixed set. So like 4 questions or four answers or something, and only one can be chosen. So that's very important to know whenever you're distinguishing between these. Multiple choice is either A, B, C, or D, or you can do numbers and do 1, 2, 3, or 4. But the user's going to type either 1, 2, 3, or 4, or A, B, C, or D. It doesn't really matter. I think most people go with numbers rather than letters. But there's only one correct answer. It's either A, B, C, or D. Can't be a collection of them. The checkbox, this is where I don't know. I understand the wording here, but I don't know why it's called a checkbox. But I would call this a multiple select, is what we did. So multiple select, question with a fixed set of possible answers. So there's going to be like 4 answers there, like A, B, C, or D, which any number can be chosen. So just make sure you read that of like, I could do A, B, and D, or I can have C and D. You know, you can have many different, you can select multiple answers. On the other hand, there is only one correct combination of choices, as most people probably are aware on those multiple select. So your checkbox is a multiple select. Your true and false, though, is either true or false. So there's not much you need to know how to do that. So to design, what you're going to do is you need to figure out in your studio, what do these types of questions have in common? What do they have in different? And then anything that every question has in common, which is probably a question, or a text of the question, you're going to make a question class. And again, you got to figure out, well, can somebody make just a question without making a multiple choice question? those kind of things. You're trying to design this. So you'll have a base class of a question, you'll have a multiple choice, you'll have a checkbox, you'll have a true false. So that's 4 classes already that we know we need to do. You need to design this with those 4. You need to have a class name, fields and properties with access modifiers, and then methods and access modifiers. So fields and methods. And the access modifiers are they going to be private or are they going to be public? That's what it's talking about there, private or public, which I'm assuming all of your fields by default will be private. And then you'll add setters and getters as needed. Any inheritance relationship. So obviously these 3 should probably inherit from question. And then should any of them be abstract? And then eventually you will design a quiz class that's going to be a collection of questions. So again, I am not expecting anybody, especially because I'm running a little later, to get done with the implementation of all of this. Your goal is to write as much code as possible, but really understand why you are writing the fields, the methods, the abstract or not. Really the design stuff. This designing the quiz class, like pulling everything together, will be the very last thing, and you probably won't get to it at the end. I will show my quiz class next time in front of you. So if you need a model, I can help with that. Implementation, putting it all together. Oh, also every program usually has a runner class to then make the quiz class that then gets the question. So, and of course there's a bonus mission, but you won't even get to that. So I'm going to answer any questions. Okay, so some people helped out finding the new module.